This is section 5.5, multiple angles and product to sum formulas. The first video for this section really is going to be what are the formulas and how did we get them. The second video that you'll see for this section is actual problems to work out using these formulas. So we want to first just start off with how did we get these. Okay, so let's start with 5.4. We did a sum of angles for a sine, and the formula we used was the sine of u times the cosine of v plus the cosine of u times the sine of v. And we're going to ask you to figure out what a double angle formula looks like. And so we're going to look at it as two x's, which is the same thing as x plus x. So I'm going to fill in my formula by putting x's in instead of u and v. So the sine of x times the cosine of x plus the cosine of x times the sine of x. And what you'll notice is although these are in different orders, they still are the same thing. So not only do I have one sine times cosine, I have two times the sine times the cosine. And so this is the first one, and I'm going to box this in a second. This is the first double angle formula, and it's the double angle for a sine. And again, keep in mind that if we asked, you should be able to do that one without having the formula in front of you, just putting two x's in instead of u's and v's. The second one, let's talk about cosine. The sum of a cosine is the cosine of u times the cosine of v. And because it was a plus, we do minus the sine of u times the sine of v. Now again, same idea. If I want a double angle, I'm going to put in x instead of u and v. So the cosine of x times the cosine of x minus the sine of x times the sine of x. Well, cosine times cosine is cosine squared of x minus sine times sine is sine squared of x. And this is our cosine double angle, where it's cosine squared minus sine squared. Hardest part about this double identity is it can get mixed up with the Pythagorean identity, so just kind of be careful there. All right, let's do the tangent one, u plus v. We're going to do the double angle, but first, the equation for the sum is the tangent of u plus the tangent of v all over 1 minus the tangent of u times the tangent of v. And like we did before, if we want a double angle, we're going to put two x's in instead of u and v. So the tangent of x plus the tangent of x all over 1 minus the tangent of x times the tangent of x. Well, the tangent plus a tangent is 2 times the tangent of x. And then you have 1 minus tangent times tangent is a tangent squared. And this is the double angle formula for a tangent. Now again, you're going to be given these double angle formulas, but it's really nice to know how they came about so that you can use them. Maybe if you forget them or you're not quite sure what you're talking about, you can easily replace them. So this is the first one. The second part we're going to do is what we call power reducing, and we're going to use these three that we just worked on to then power reduce. So here's how it works. Let's slide down to our power reducing ones. We're going to start with the double angle identity we did for cosine above, in hopes to end up with a power reducing formula for sine squared. Well, the double angle for cosine was the cosine squared of an angle minus the sine squared of an angle. All right, and we give you directions to kind of follow. Instead of cosine squared, let's replace it with 1 minus sine squared. That's the Pythagorean identity one. So we have 1 minus sine squared, and then minus another sine squared. Well, if I have a -1 sine squared and another -1 sine squared, I have 1 minus 2 sine squared. Okay, this is the first idea. What we're going to do now is take this equation and we're going to solve it for sine squared. So I have the cosine, the double angle for cosine equals 1 minus 2 times the sine squared. So I'm going to start solving. First, subtract 1. Cosine squared minus 1 is negative 2 sine squared. When I divide by negative 2, then I get that sine squared, and I'm going to kind of rework this. This will turn this into a negative and turn this into a positive, so I'm going to write this a little bit different. I'm going to say 1 minus the cosine of 2x. It's supposed to be an x. Cosine of 2x. So 1, because this is a positive 1 then, minus this, all divided by 2. Because I don't necessarily want to see the negative there in a denominator. And so this is my power reducing formula. And again, we're going to give you that power reducing formula, but I just wanted you to know where it came from. We're going to do the same things in hopes to get the cosine squared. So the double angle for cosine again was cosine squared minus sine squared. And they suggest that now this time you replace sine squared with 1 minus cosine squared. So cosine squared minus, and I'm going to replace this, 1 minus cosine squared. This negative gets distributed, so you have a cosine and a positive cosine, which is 2 cosine squared, and then the negative goes to the 1 to make minus 1. We're again going to take that formula, so the cosine of a double angle equals 2 cosine squared minus 1, and our goal is to solve for the cosine squared. So I add 1, and then I divide that all by 2. I'm going to shorthand this a little bit. And what you get, and I'm going to put the 1 first, but 1 plus the double angle of cosine divided by 2. And this is what we call a power reducing formula for cosine. Okay? And then the last thing we ask you is, well, could we do it for tangent squared? Well, sure, because tangent is sine over cosine. So if tangent squared is sine squared over cosine squared, I have a formula for each of those. So here we go. My formula for sine squared, 1 minus the cosine double angle divided by 2 over 1 plus the cosine double angle divided by 2. Well, the 2's cancel out, which is wonderful. So what answer do I get? 1 minus the cosine of a double angle divided by 1 plus the cosine of a double angle. That's the power reducing formula for tangent. Okay, and again, we're just trying to show you where they come from. The things that I'm boxing in, you might want to highlight a box and whatever. You've gotten a formula sheet for chapter 5, but this is the formulas and this is how somebody decided the formulas were going to be like this. Okay, let's move on to the back side. We now have this half angle, and the half angle is really nice for us because sometimes they want a half angle like, I don't even know, like, you know, they might want half of 135, and so we have to use an angle we know. And so this is that idea. Sine squared is 1 minus the double angle for cosine all over 2. And that's the one we just went through. Okay? So here's what we're going to do. Instead of sine squared, we're going to take sine squared of x over 2, what we call this half angle. And so everywhere I see an x, I'm going to put in an x over 2. So 1 minus the cosine of 2 times x over 2 all over 2. And you'll notice these cancel out. So I'm left with 1 minus the cosine of x all over 2. Now, we don't want sine squared, we want just sine. And so if I don't want the squared anymore, they say just get the sine of x over 2, I'm going to square root this side, and if I square root that side, I also have to square root this side. Now, when you square root, there are always two answers. So we have plus or minus the square root of 1 minus the cosine of an angle, all divided by 2. And this is what we call the half angle. Now, the reason we have this plus and minus is because the sine will be positive in quadrants 1 and 2. The sine will be negative in quadrants 3 and 4, and so it really depends on kind of where you're at. That's the first one. The second one is a power reducing for cosine squared, or the cosine of x over 2. We want that half angle. So we start with cosine squared. So 1 plus the cosine of a double angle divided by 2. And like we did before, we're going to say instead of cosine squared of x, we're going to say cosine squared of x over 2. So I'm going to replace, again, like I did before, the x with x over 2. And the same thing will happen. I will get 1 plus the cosine of an angle divided by 2. Again, we don't want cosine squared, we just want cosine. So we square root these. And when you square root, you get plus or minus 1 plus the cosine of x all over 2. Again, I'm going to say why the plus or minus. Cosine is positive in quadrants 1 and 4, and it's negative in quadrants 2 and 3. And so it depends on where our angle is, what positive or negative we're going to use. Now the tangent one I'm not going to derive because it takes way too long, but at least let me give it to you. The tangent of your half angle is, and there's two ways to write it, and we give you this in your on your yellow or your formula sheet, but 1 minus the cosine of x over the sine of x, or you could write it as the sine of x over 1 plus the cosine of x. And so you have both of these options to use, but there's your half angle for a tangent. Okay, you will notice at the bottom that there are some other sum to products and products to sum formulas. Basically, it's really, do you know how to use them? Can you plug angles in? Things like that. So that's the end of the first video for 5.5. Please stop this and then open up the second video, because in the second video, what we're going to do is actually problems using all of these formulas. So that's all for 5.5. Again, don't forget, watch the second video.